So hello guys, so today's our question is that we have been given a rectangle R0 which has a side of length 3 and 4, and another three rectangles are given named R1, R2 and R3 such that they form a structure like this. The property of this structure are given as follows. Rectangles share a common vertex at P, name this point as P, and one side of Rn is a diagonal of Rn minus 1. This means that, for example, let's take R1, its one side is a diagonal of R0, and for R2 its one side is a diagonal of R1. Same for R3 to R2. Opposite side of Rn passes through a vertex of Rn minus 1. This means that let's take R3 rectangle, so its opposite side are like this, so they passes through a vertex of R2, and same for R2, these opposite sides of R2 pass through vertex of R1. Same for R1 to R0, such that the center of Rn is located counterclockwise of center of Rn minus 1. This means that, for example, um, this this is the center of this R3 rectangle. So, and this is the center of R2. So they are moving counterclockwise. This is the meaning of this statement. So we have been asked to find the total area of this structure. Okay. Some students apply the Pythagoras theorem to find the all sides of a rectangle and diagonals to find the total area. But this method is quite long, and they even don't get a accurate answer. So I'm going to apply the method of as this structure is moving at a certain rate. So it will be okay too if we take two example of rectangle to prove some relation. So I'm going to take the example of R1 and R0. So this is R1, this is R0. Name this point as A, M, N, P, B. Now draw a perpendicular from A to the diagonal PB. Name this point as C. And from diagonal properties of a rectangle, we can see that area of triangle APB should be half of the area of R0. And we can also see that R1 rectangle is divided in two parts, which are MAPC and NACB. So for rectangle, MAPC, its area should be equal to the sum of these two triangles, MAP plus area of APC. Similarly, for the rectangle NAPC, NCB, its area should be equal to the sum of the two triangles, which are area of A and B plus area of uh, ACB. Again, from diagonal properties of a rectangle, we can see that this this triangle should be equal to this triangle, and this triangle should be equal to this triangle, as the diagonal divides a rectangle into half parts. So again, we can write these two equations as MAPC equal to the 2 times of area of APC, and NACB equal to the 2 times of area of ACB. Now if we add these both equations, we will get the total area of rectangle R1, which is 2 times of area of APC plus area of ACB, which is times of area of APB, and as this is the half of the area of R0, so this would be the answer. Now we can find the same relation for the other rectangles, and the ending result should be like this: R3 equal to R2, R1 equal to R0, which means that the all rectangles have the same area. Now it should be easy to find the whole structure area, because we need to just find the uh, area of these triangles and this whole rectangle. Yeah. As the area of the whole rectangles are same, so area of all triangles should be same too. So area of triangle half of 3 into 4, which is 6, and there are three times of this same triangle, so 6 into 3, 18. Now area of rectangle R3, which is 3 into 4, 12. So total area of whole structure should be the sum of this area and this area, which is 30.